progress. Let us see the topic matrices. Okay. To explain this, let us take me one example. Like say for example, there is a field. Okay. These are the boundaries of the field. Okay. These are the boundaries of the field. And in this field, how they plant the plantings, how they will plant one, here one, here one, here one, here one, like this and so on this side and like this and so on this side. It goes continuously till they completed the grass, small plants will be there, no? Okay, like this. We will see in regular life, no? Whenever you go to villages and something, you can see like this fields and plants. Okay, here what you can see? Here what you are observing here, these are planted in a particular manner. Particular manner is there. Yes? Yes or no? Here particular manner is there to plant the grass plants. How they are appearing to us? It's in a some particular order. Okay? So by this seeing we can say one thing. What? Here this side and this side. It's an order, right? So this line will be called it as rows, and this side will we call it as columns. So by this what you can say, this is an arrangement of plants in rows and columns. That is nothing but matrices. This is nothing but, this type of arranging the data is nothing but matrices. Okay. So how we can write a matrix? Say for example, take one matrix, and the matrix is always started with a square bracket and some numbers. Okay, like this. A, B, C and so on this side, and here B, C and so on this side, like this. This type of arrangement of data is called as matrix. So let us come to the exact definition. Let us come to the exact definition of matrices. Arrangement of data in rows and columns is called as a matrix. Is called a matrix. Okay, and how we can indicate that? Square brackets. Let us take a letter, and here I, J, here A11, A12, A13 and so on, A, I, J, here A21, A31 and so on, AN1. Like this we denote the matrix. Here if you observe, we are writing here down 1, 1, 1, 2 and so on, here 2, 1, 3, 1 and so on. What is this? This is nothing but the row number, and this one is row number, and this one is column number. Okay, A11 denotes this one row and this one column. Number of row and number of column. Like this we identify. Like this we identify the mat. This is an element in the matrix, and this is one full matrix. So how to indicate that? Let the whole matrix is given a name. Whole matrix is given a name, that is capital A is equals to is equals to is equals to like this, a square bracket. Let us take an example. Example A, 1 2 3 4 5 6 7 8 9. I took a matrix in this way. Here, how we can indicate this? Let us given this also one number name. A11 is 3. That is first row, first column. A11 equal to 1. Sorry, 1. Next, A12. That is first row, second column is 2. Next, A13. First row, third column is 3. In the same way, A21. This is 1 1. This is 1 2. This is 1 3. And this is 2 1. That means second row, first column is 4. Next, A second row, second column is 5. Next, A, this is 2 2 and this is 2 3. Second row, third column is 6. In this way, we can denote the each element of a matrix. Okay, each element of a matrix. While denoting the element of the matrix, we must specify the row number and the column number. First, we have to specify the row number. Next, it is the column number. Okay. Here, what is the element is there here? 1. So, write that element in that particular position. Like this, we indicate the matrix. Okay. This is the, and one more thing here, for this order is there. Order of matrix. Here the order is nothing but number of rows into number of columns. Number of rows into number of columns is nothing but order of the matrix. In this example, you can see how many rows are there? First row, second row, third row. So number of rows is 3 into number of columns, first row, second row, third row. That is 3 by 3. What we call this as? Call it as 3 by 3 order matrix. What it means? We call the product of rows and columns is called as order of the matrix, and the order of matrix is given by the number of rows and into columns. Here I got, for this example, I got 3 by 3, and we will read it as 3 by 3 ordered matrix. Okay. 3 by 3 ordered matrix. Next, types of matrices. First one is square matrix. Let us see directly example. After seeing that, we will understand it easily. So, let me take a square matrix. Let me take a matrix given name B is equal to say, for example, M N O P Q R S T U. As an example, you can take any letters or numbers or combination of letters and numbers you can take as elements for example. Okay. So B is a matrix with how many rows? 1, 2, 3 rows. 3 into 1, 2, 3 columns. So what we call this as order of matrix. Don't forget it, ma. Order of matrix. Okay. Now here what we observe, how many rows are there? 3 rows. And how many columns are there? 3 columns. If any matrix with same number of rows and columns, same number of rows and columns is called square matrix. Got it, ma? Square matrix. Okay. If any matrix with same number of rows and same number of columns is called as square matrix. Let us see one more example for this. Say for example it is given I, not I, take it as N. Say for example capital N is A, B, C, D, sorry, A, B, C, D, E, F. Here what you observe, ma? Take this example here. How many rows are there? First identify the number of rows and columns. Whenever you got a matrix, then after seeing it, let us observe the number of rows and columns. It's the important point. Okay. So here how many rows are there? This is first row, this is second row, and this is third row. Okay. So first we have to specify the row number into. And next what we have to specify the number of columns. This is first column and this is second column. How many columns are there? 2 columns. So what we call this as again order. Order of matrix. But here what you observe? The 2 are different. The number of rows and number of columns are different. Okay. So if you have like the different, that is not a square matrix. A square matrix have 2 same number of rows and columns, but here we didn't have that, no. So this is not a square matrix. Okay. Next, yes. Okay. Next, take one more example. Other point in the square matrix. Let us take one more example. Okay. One more example. -1 0 0 0 minus 1 1 0 0 1. Okay. Otherwise you can take one. Let's take one more other example. Say P Q R S T U V W X Y Z A. Like this, it is there. Again, this is not a square matrix. Now let us take one more row. 1, 2, 3, 4. Okay. Okay, like this I took one more matrix. One more matrix. And this is, what is the order of this one? What is the order of this matrix? It is 4 by 4. And this is also a square matrix because the number of rows and columns is equal. So, this is also a square matrix. And if you observe these elements of the matrix, whether it is the 4 by 4 or 3 by 3 or 2 by 2, okay? If you observe this middle, means here what we can say exactly, this is A11, this is A22, this is A33 and this is A44. the elements which have the row number and column number same, those elements of that particular matrix are called as principal diagonal. Got it, ma? Here, if you observe here, take P. It is A11. That is first row and first column. And this T, if you take A is second row, second column. X here, A, third column. Sorry, third row and third column. Here 4 is fourth row, fourth column. So the elements with same row number and column number, all the elements in the same row and column number are called as principal diagonal or just diagonal. Okay? Okay, ma? Next, if you take these elements, sum of these elements, that is P plus E plus X plus 4. If we do the sum of the diagonal elements, we call that as trace of that particular matrix. That is denoted as PR of, what is the name given here? For this it is given, say for example X. Okay, trace of matrix X. Okay, this is the trace of matrix. Sum of the all diagonal elements or principal diagonal elements of a matrix is called as the trace, and it is denoted by TR of whatever the name given for the matrix that you have to specify in the brackets. Okay, got it? This is